A titration curve for a weak acid, e.g., acetic acid, CH3COOH, and a weak base, e.g., ammonia, NH3, depicts the changes in pH of the solution as the weak acid and weak base react. Here's a concise overview of the essential points. X-axis. The x-axis represents the volume, usually in milliliters, of the weak base solution added to the weak acid solution. Y-axis. The y-axis represents the pH of the solution. 3. Initial pH. The initial pH is determined by the dissociation of the weak acid and is generally higher than that of a strong acid due to its partial dissociation. Buffer regions. These regions correspond to areas where the pH changes relatively slowly as the titrant is added. Equivalence point. The pH at the equivalence point may not be neutral and can vary depending on the strengths of the acid and the base. Shape of the curve. The curve shows gradual changes in pH throughout the titration process, with multiple buffer regions leading to a more intricate curve shape compared to that of strong acid or base titrations. Endpoint. An indicator is used to determine the endpoint of the titration, indicating when the color change occurs and the reaction is complete. Neutralization reaction. The reaction between the weak acid, CH3COOH, and the weak base, NH3, results in the formation of the acetate ion, CH3COO, and water. The titration curve for weak acids and weak bases is more complex than those for strong acids and bases, primarily due to the presence of multiple buffer regions. It provides insights into the behavior of weak acids and weak bases in solution and aids in the determination of their concentrations based on the volumes of the titrant required to reach the equivalence point.